Hi, welcome back to your new lesson. This is Lakshmikant Tiwari. In previous lesson, I had taught you about the logistic regression in Python using a Titanic dataset. And I had also told you that I'll be making another part on the logistic regression in which I'll be talking about the feature selection and accuracy, ROC, AUC, curve, etc. So if you see here in this lesson, in the previous lesson, in the part 1, I have taught how you can prepare your data, how you can impute the null values, and then how you can finally convert categorical variables into a numerical data, and then finally how you can build your logistic regression model. And we had achieved 82.71% accuracy. But in this video, I'll show you how you can work with recursive feature elimination, how you can select a feature with recursive feature elimination techniques, and we will be achieving 85.47% accuracy by using recursive feature elimination. And after that, I'll be telling you how you can calculate accuracy, F1 score, precision, recall, AUC, ROC curve. And once you have got each curve, etc., the accuracy matrices, then I'll tell you how you can calculate the ROC curve. Okay, so this will be a little bit the lengthy code, although I'll be talking about this in the detail. So without wasting a time, let's go ahead and start our tutorial. Recursive feature elimination is a process of feature selection by selecting a features recursively. So here is an algorithm for recursive feature elimination. First of all, that we need to train our model through the training set using all predictors, and then we calculate the model performance. Once we get the model performance, then we calculate the importance or ranking for each individual features. And once we get all the individual features, then we remove a least important feature from that subset of the features. And we keep doing that until we get our specific set of the features. Let's say we have 100 features and we want to just select 10 features. In that case, we will start with the 100 features. Then we will rank the feature set, and once it is ranked, then we will remove the least ranked features, let's say 100th place feature, and then we will again train our algorithm. Then we will again calculate the model performance and recalculate the ranking for each feature set, and thereafter then again we remove the least important features. And we keep doing until we get our top 10 features, a subset of the features. And once we get those 10 subset of the features, then finally we calculate the model performance and we profile the performance of the model, and then finally determine other accuracy metrics of a model. We can get it by using just the coif and the feature importance attributes into sklearn. So sklearn has really made this very simple for us. So let's go ahead and implement recursive feature elimination into our logistic regression example. First of all, that we need to import RFE module from sklearn, that is the recursive feature elimination. So that we can get from sklearn dot feature selection, import RFE. Once we get that, let's go ahead and get our X. I think we already have our X. Okay, so let's go ahead and first create a model. Here model is equal to logistic regression, and the solver we are going to give here LBFGS, and then we are going to give here max iteration 200. Once we have this max iteration, then we are going to create here RFA, that's the recursive feature elimination. Then we are going to pass here our model for which we are going to do recursive feature elimination, and then finally we are going to select a number of subset of features which we are going to consider in final evaluation. If you press here shift and the tab, then you will get here the number of the input which takes this RFE method. So it takes estimator number of features to select. So we are going to select 5 features out of, I think we have 7 features. Let me see how many features we have. We can get with except we have total 9 features. So out of 9 these features we are going to select top 5 features. I mean the top 5 highly performed a subset of the features, and this is going to be in step of 1. That's mean each step it is going to perform. Let's set our verbose is equal to the 1. Okay, perfect. So step equal to the 1, that's mean each time it will eliminate just a single feature. Perfect. Now let's go ahead and create RFA dot fit. Sorry, here we are going to fit with our x and y. Perfect. Now you see here the first it has fitted with 9 features, 8 features, 7, and finally with the 6 features. It says that it has failed to converge. Let's go ahead and put it 500, and now it has fitted with 9, 8, 7, and 6. Okay, finally let's go ahead and see how many features, I mean which features it has got, and we can get that with the RFE dot support attribute. So this says that the first, and then this one, and this and this. So these are the only features which we have got. For to understand this into the detail, what we can do, we can get it here with this one. Okay, now you see here the survived is not our the column. In fact, you see here we have these columns only. So we have a passenger class, but the sex age has been dropped. We have got here the sibling, and then parents and the child, and then finally whether the person is adult or not, and then finally this one. So these are the 5 has been selected. Okay, now let's go ahead and create our x here. So in this case, if we get this, yeah, head, right? So in this case we get this one. Now let's go ahead and select only the column which this recursive feature elimination has returned. Okay, to select only those features, what we can do, we can say here double x is equal to x, and then x dot columns, and we are going to just select column with RFE which has written RFE dot support. Okay, now if you see here double x dot head, so these are the only 5 columns which recursive feature elimination has returned. Now let's go ahead and test the accuracy for these subset of the features. Okay, perfect. Now let's go ahead. I think instead of writing a full code, what we can do, we can just go ahead and in fact we can just copy it, and let's go ahead and paste it here. Okay, perfect. So we don't need this one. So here we have x train, x test, y train, y test, and here in input we need double x. Since we have got feature eliminated into the double x, The test size is 0.33. Here we are going to set here the test size 2. A random state is going to be selected, let's say 8. And one more thing, we are going to set here a stratify. Stratify is y. If you double click here, shift and tab, then you will get here the random state and the stratify. Stratify says that if we make here stratify y is equal to the y, then it will create test and the train sample by putting just 80% into the test train sample and 20% in test sample of y. That's mean y will be equally distributed in between test and the train. Okay, now here we have Qdrant. Now let's go ahead and see here our the model performance with the 400 or 500. Okay, LBGS. Perfect. Now you see here we have got here 85.47% accuracy, right? So this is the great accuracy. Earlier we had got just the 82% accuracy. You see here 82.71% accuracy, but with the feature elimination we have got 85.47% accuracy. Now let's go ahead and implement accuracy, F1 score, precision, recall, and AUC and the ROC curve. Here you see here we have just got a score, but suppose that if I ask you to calculate F1 score, recall, precisions and accuracy and the ROC curve, then how would you do this? To understand the accuracy, precision and the recall, you need to first understand what is the true positive and false positive and true negative and the false negative. The true positive, they are correctly predicted positive values, which means that the value of actual class is S and the value of predicted class is also S. Okay, that's mean that will be the true positive. And the true negative means they are correctly predicted negative values, which means that the value of actual class is no and the value of the predicted class is also no. The false negative means the value of actual class is yes, but the predicted is no. That is the false negative. However, the false positive means that's when it's a false positive. The predicted is positive, but the actual is negative. That means that is the false positive. So in that case, the precision would be the true positive divided by the actual results. That means the true positive divided by true positive plus false positive. And the recall is the true positive divided by the predicted result. That's when the true positive divided by true positive plus false negative. And the accuracy is the true positive plus true negative divided by the total. Okay. Now let's go ahead and implement this using sklearn library. Okay, and then finally we will implement this ROC curve, that is known as a receiver operating characteristics curve. So here we have from sklearn dot model selection, import train test split, and then we have cross validation score. Then we have here from sklearn dot metrics. Then we have here accuracy score. Then here we have classification report. Then here we have a precision report. Then we have here precision score, and then we have here recall score. And after that we have from sklearn dot metrics import confusion matrix, precision recall curve, ROC AUC score, ROC curve, AUC, and finally log loss. And once we have all the metrics here, now we are going to train our model. Okay, to do that, what we can do, we can just go ahead and copy our model. But here you see, here we already have xtrain, xtest, etc is splitted. So what we can do, we can just copy it here and we can just paste it here. And then finally, once we do this, now we have got our the y predicted. Okay, that's the y prediction. Once we get our y prediction, then we are going to calculate the y prediction probability. Okay, y prediction probability is equal to model dot predict probability. Okay, in this case we are going to pass here x the test. Okay, and then we are going to take here all the rows of first column. Okay, now we have got here y pred probability. Once we have got the y pred probability, now we are going to get here, even though if you double click here, shift and double tab, then you will get here, it estimates the probability of all the classes. Okay, whether person is going to survive or not, it will return in the form of the probability. Now we are going to calculate here ROC curve. Okay, for the ROC curve we are going to write here ROC curve, and in the parenthesis, if you press shift and the double tab, you will see here it takes the y true, y score, and the position label, sample weight, drop intermediate, etc, and then finally it returns the compute receiver operating characteristics, ROC. Okay, perfect. So in the form of the return, it returns the these array FPR, which is false positive rate, and then TPR, that's the true positive rate, and then it also returns the threshold. Now let's go ahead and get all those three values in a list, and that list is false positive rate, true positive rate, TPR, and then THR threshold. And in ROC curve we need to pass here y test and then y underscore predict probability. Okay, perfect. Now once we have this, then now we are going to print our the accuracy, log loss, and AUC. Okay, so here you see here we have got the accuracy, and in the accuracy we have model dot accuracy. Sorry, we can say here accuracy score, and inside the accuracy score we need to pass here y test and then y underscore predict. You see here the accuracy we have got 85%. Okay, and similarly we are going to print here a log loss, and in the log loss you see here we have y test and y underscore predict probability. Now the log loss is 0.359. okay, and then finally we are going to print here AUC. That's the AUC curve, AUC value. Okay, and in the AUC we are going to pass here FPR, false positive rate, and the true positive rate, and here we have AUC 0.90. right? Perfect. Now what we are going to do here, now we are going to calculate our ROC AUC curve. Okay, this curve. Okay, to do that, to calculate that curve, we need to first get the minimum of minimum of the true positive rate, okay, where TPR is greater than 0.95. okay, so that we can get here with the IDX is equal to NP dot mean, and there we can type here NP dot where TPR is greater than 0.95. okay, so once we have this IDX, you see here, that's the 27. okay, now once we have the IDX, let's start with the plot. Here we have a PLT dot figure, and then PLT, here I have a PLT dot figure, then I have a PLT dot plot, then here FPR, false positive rate, the true positive rate, and then here we have a color is coral, and then here we have a label is equal to ROC curve, and then area is equal to, let's say, the 0.3%. okay, perfect. FPR, and then here we have a TPR. okay, then we have here the PLT dot plot. Now you see here it is going to, the plot here a line, this line, okay, FPR and the TPR, etc., etc., true positive rate and the false positive rate. okay, now let's go ahead and do and plot this line. So to do that, what we can do, we can pass here 0 1, and then this one. Then here we have a PLT dot plot, FPR, here we have IDX, right, then here we have a TPR, then IDX, then here we have a TPR, IDX. okay, color is equal to blue. So it says that AUR is not defined. Let me see, I think this one, this is AUC. This says that this line is somewhere. Unsupported character somewhere. Let me see where it is. Okay, now you see here we have got our the ROC AUC curve, although there are the few things which is left to make it right. To do that, what I can do here, I have already written that code. To then I can just copy it and paste it there for simplicity. Then I'll explain you what those codes are doing here. You see here there are blue lines for positive rate and the false positive rate. Now the one blue line will be here, and the first one is this one, the second one will be drawn here at a 0.90, and then here it is setting the x limit, then y limit, then this is setting x label, y label. Here it is the title, legends. Okay, now let's go ahead and plot this. Now if you see here, the ROC curve area is 0.90, right? And if you see, this curve is almost similar to this curve. So this is all about in this lesson. In this lesson we have learned about recursive feature elimination, accuracy, F1 score, precision recall, and the AUC ROC curve. Okay, so the moreover you have learned how you can plot ROC AUC curve in this lesson. Thank you so much for watching this video. Please do not forget to subscribe this channel. Bye bye, have a nice day.